Hi everyone, it's Mrs. Woodruff here. Today's video is going to concentrate on reviewing solving linear systems. We've actually been introduced to three different ways. The first one was graphing, the second one was substitution, and the third one was elimination. So before we go any further with elimination, I thought we'd take a step back and just remember those three methods. And you have notes pages for these first two that I'm going to do. So the first one was, how do we solve a system by graphing? So the first thing we notice is that our equations are in y equals mx plus b. So we look to that b, remember, which is the y-intercept, and we're going to go plot it on the y-axis rather. I'm going to start by putting a point at -4 on the y-axis. That's my y-intercept. I'm going to go back over and look at my slope. The top number is rise, the bottom number is run. So I'm going to position myself on that y-intercept, and I'm going to rise 2 and run 3. Since they're both positive, we're going up and to the right. I'm going to do that again. I'm going to rise 2 and run 3. And now I have the start of a line. Remember, we would pick up our ruler and we would make a nice perfectly straight line. Accuracy matters here, because we're looking for the point where the two lines are going to meet. So I'm going to use my straight line tool here. You would use your ruler, and there is the first line. Now I'm going to go and graph the second line. So when I look at the second line, that line has a y-intercept of -5, so I'm going to come down on the y-axis to -5. That's my start point. I'm going to use my slope to move, but my slope here is missing. It's the invisible 1. So I'm going to position myself in that y-intercept, and I'm going to go up 1 and to the right 1, so 1 over 1. I'm going to do that again. And I usually, on the second line, keep using that slope until I hit the other line, and you'll see right there I did that. I'm going to pick up my ruler again, or in my case, my straight line tool, but you're going to pick up your ruler, and we are going to draw that line in. And again, trying to be as accurate as we can, because the important thing is, where do they meet? And we can see that they meet at this point right here. Let me get this. I have this already done, so there are the two lines. So the solution is the intersection point, which in this case we can see right here. And we notice we start at the origin, we go 3 to the right and 2 down, 3 in the x direction and -2 in the y. So our solution to this system would be, 3, -2. We talked about checking it just to make sure that we didn't wiggle our ruler or make a mistake on how we plotted our lines. So we're going to put the 3, that is the x coordinate, into the x spot here. We're going to substitute that in. We're going to take the -2, since it's in the y coordinate, we're going to substitute it in for y. We're going to do that in both equations. And you remember, this was what was called a check. And we need to make sure that we get a true statement at the bottom of both of those, which says that that point is on both lines. So that was solving a system of equations using the graphing method. We then realized that not all lines are going to meet on the crosshairs in the 4 corners. So you could have an answer that's fractional, and the graphing method fails. So we went over to something called solving substitutions by a substitution. And we started with one that kind of looked like this, where they were both y equals. And instead of picking up graph paper and a ruler, we substituted. So since this y equals -4x minus 19, we went into the top y, took him out, and brought up his other name. So it would look like this. This led us to an equation with a variable on both sides, which we have solved earlier on in the year. Now, look at the two x terms. One's on the right and one's on the left. They're on opposite sides of the equation, so in order to get them together, we have to do opposite operations. So you're going to see me add 4x to both sides. You did have a choice. You could have subtracted 3x and still gotten to the answer, but you know how I like to be positive. So this is a 0 pair. We're going to have a -19. Make sure you don't cut that arm off, that negative. And over here, we're going to have 7x plus 2. So we now have a two-step equation. This is where you would come through and Woodruff bubble the 7x. And it's a two-step equation. So I'm going to get my eye on this plus 2 and undo it, move it to the opposite side by doing opposite operations. So I'm going to subtract 2. I've created a 0 pair here, leaving just the 7x plus 0. So I only have to write 7x. And on the other side, I have negative 21. Now we're down to a one-step equation. And to solve that, the opposite of multiplying by 7 would be to divide by 7. And I've got my x coordinate. Now, one of the mistakes we were having is folks kind of stopping here. You only have half the answer. Right now, you only know that the x coordinate where these two lines meet is negative 3. But what is the y coordinate? So now we're going to go back up and substitute that x equals negative 3 into either of these equations. And I chose to do it in the top one. So you see the y coordinate equals 3 times the x coordinate plus 2. And that's where I put the substituted the negative 3 in. So now I do my order of operations. So I'm going to multiply before I add. And when I add negative 9 plus 2, I now have the y coordinate. So those two lines, I believe, meet at the point negative 3, negative 7. But again, I'm going to check it. Now, since I just used this top equation to get that second coordinate, I really only need to check it in the bottom one. And that's what you're going to see me doing here. Again, multiply before I add. And because I get that true statement at the bottom, I am a happy girl. We went one step further with substitution, where what if they were not both equal to y? We do not have to solve the bottom one for y. As long as we have one equation solved for one of the variables, we can go into that second equation, find that variable, in this case y, remove him and replace him with what his other name is, in this case 3x minus 9. This led us to the distributive property, which you guys did a great job in the fall with. 3 times 3x is 9x, and 3 times 9 is negative 27. Now, if you look at these two x terms, they're both on the left side of the equal. They're on the same side, so we do the same operation. We add them together. Woodruff bubble would be coming in here, and we would add 27. Divide by 15, and again, realize you only have the x coordinate of where these two lines would meet if we graph them. So we need to find the y coordinate. So we're going to take that x equals 2, and we're going to put it right up there. We're going to substitute for that right there and have 3 times 2 minus 9, which is happening right here. And when we take 6 minus 9, we get the y coordinate. And again, I'm going to check it in the other equation, the one that had the coefficients of the 6 and the 3 equaling 3, and it works. And now I'm still a happy girl. The final method that we learned was called elimination. And we had a system like this, and we said if it was arranged properly, so the y over the y, the x variable over the x, the equals over the equals, the numbers over the numbers. If you look at this, it's arranged properly. The second thing we were looking for was there a coefficient, a number in front of one of the variables that was the same but off by a sign? And if you'll notice, there's a 3 and a negative 3. And what we discovered is if we add down, we'll get a 0 pair here and eliminate the y and end up with 2 x's equaling 42. Once we have the 2 x's equaling 42, it's a one-step equation, and we're able to get to the x coordinate pretty fast. Now we're right back where we were before with the other method of substitution, and that we need to substitute that back in. And you'll notice I'm taking that top equation right here, taking out the x and substituting the 21. It's now a two-step equation. Not going to touch that 3 yet. I'm going to subtract 21, then divide by the 3, and I got my solution. Just like substitution, if I'm going to check this, I need to check it in the equation I didn't use right here, so I'm going to need to substitute in the one that has that 30 at the end. And when I do that, I have a good answer. You'll notice I checked it in both. You'll remember I told you that if you're not sure which one to check it in, check it in both just for that confidence. So that's kind of where we left off, and I have put the answer key out on Google Classroom for the first day of elimination, but now I'm going to go on and talk a little bit about what if. What if things aren't so perfectly ready to eliminate? So what I would advise you to do at this point in time, just to get the rust out since we haven't been together for a week, is to pause the video and to solve these two. And when you come back, I will show you the answers just to make sure that you are comfortable being back into the process of elimination. Okay, guys, now that we're back together, let's see how you did. So let me just uncover the answer. So this one should have been -2, 3. When you added down, you should have gotten right away to 2y = 6. When you divide by 2, you're going to get the y coordinate of 3. Now be careful. Did you plug it in for the y? Make sure you didn't plug it in for the x. And when I do that, I solve down and I got the x coordinate of -2. Notice I used the top equation to get the x coordinate, so I have to check it in the other one. And over here, did you get 3, -1? When you add down this time, the x eliminates. Should have gotten it y coordinate of -1. I chose to put it in the top one. Now be careful, that's the opposite of -1, which is +1. I'm going to subtract 1 from both sides, divide by -5. Should have gotten 3 for the x coordinate, and I have to check it in the one that has the 17, and there's my check. If you need to, pause this so you can check your work if you have a mistake. If you're not finding it, you are welcome to take a picture and email it to me, and I will find your mistake for you. But let's talk about what if. So if you take a look at this system, looking at the coefficients of x, notice they're different. And if you notice the coefficients of y, they're different too. So I need to have either this coefficient, or these coefficients, I should say, be the same and off by a sign, but they're not. So this is where that multiplication step is going to come in. And we're going to change one of the equations. As long as we multiply the entire equation by the same number, it will still be the same equation. So I'm going to multiply this top equation right here by 4. So 3x times 4, the -10y times 4, and the -25 times 4. And when I do that, there is 3 times 4 would be 12 with the x, -10 times 4 would be -40 with the y, equals, and -25 times 4 would be -100. And now we're back to having what we need, that we can just simply add down and eliminate the y. So I'll get 16x, this would be plus a 0 pair, equals, and -100 plus 20 is -80. One-step equation here, just divide both sides by 16, and I've got the x coordinate. I'm going to take that x = 5, and I'm going to substitute it into the top equation, the original equation that I didn't touch. I'm going to put that x = -5 right there, and I'm going to do the math here. So I'm going to get -15 minus 10y. Now we're not going to touch this -10y. If you need to, you can change that minus to plus a negative. And you're going to see, to make a 0 pair, I need to, let me just do that, I need to add 15 to make the 0 pair. So I'm going to add 15 to both sides, and I get 0 minus 10y equals, and -25 plus 15 is -10. Make sure you didn't lose that negative that I'm pointing to right there. I'm going to divide both sides by -10, and my y coordinate is 1. I've got my x, I've got my y. If I had graphed these lines, they would have met at the point -5, 1. Now, where am I going to check it? Well, look at the equation I used, this one with the -25, so I've got to check it in this one. So that x is going to become the -5, and that y is going to become the 1, and I'm hoping the math is going to work. 4 times -5 is -20. Add it to 40, it is 20, and I remain a happy girl. Okay, so why don't you try this one? Well, yeah, actually, let's do it together, because this one I forgot. We're going to have to multiply both equations this time. So there's no kind of nice number that I could multiply one over the other equation by. So I'm actually going to multiply both equations, and they're going to be by different numbers in order to try to get these coefficients to be the same number but off by a sign so I can add and eliminate. So just take a look and think about that for a second. And let me show you what I chose to do. There's more than one way to get to this answer. So here I chose to take the top equation and multiply by -4. I'm looking to get a -12 right there. To get the number that I need on the bottom, I have to multiply the bottom equation by 3. And when I do that, you'll see where I'm heading. So -4 times 3j is -12j. -4 times 5k is -20k. And -4 times 19 is -76. The bottom equation can be multiplied, or it is going to be multiplied by a different number. So when I take 3 times 4j, I get 12j. 3 times that -8k is -24k, which is the same thing as -24k. And 3 times -4 is -12. Let me just stop and tell you that the number one mistake is often kids forget to multiply these constants by these numbers. They leave them as like 19 and -4. Remember to keep the equation in balance. The entire left and the entire right has to be multiplied by the same number. And here I go again. I'm ready to eliminate. I add down. I get -44k equals -88. Divide by -44, and I've got the k. K equals 2. I'm going to put that 2 back in to, you'll see the bottom one this time. Oops. And when I do the math there, here's the Woodruff bubble coming. I'm going to add 16, divide by 4, and I get the j. Now I'm using a different variable in here just because I wanted to remind you that sometimes science and just applications will use different variables. They don't always have to be x and y. So when you have two different variables, you can't really write your answer as a point, or if you choose to, make sure you put it alphabetical. But right now, this is one case. I'm just going to leave it as k equals 2 and j equals 3. I'm not going to write it as a coordinate pair. I checked it in both. I really only had to check it in the one that starts with the 3. Matter of fact, if you kind of look here, you can kind of see sort of the similar math kind of happening. And that's how we do it, by changing both equations. So here's a chance for you to give one a try. So stop the video and try it. And in a second, we'll get back together. Please realize there's more than one way to do this. So you might not have chosen my way, but if you've got the answer, you're in good shape. Okay, guys, we're all back together. I'm going to show you what I chose. I chose to multiply the top equation by -3 and the bottom one by 2. That is not the only way to do this one, but let me just show you how I did that. So when I multiplied the top one by -3, I got -6x, positive 9y, and 0 times -3 is 0. 3 times 2 is the 6 in front of the x, -2 times 2 is the -4 or -4 in front of the y, and 5 times 2 is 10, and I'm ready to eliminate. I add down, I get 5y equals 10, divide by 5, and boom, I've already got the 2. All right, my computer's doing that a little bit today. I'm going to put the 2 back in, and I chose to do it in the top equation. Here comes my two-step equation, Woodruff bubble. I'm going to add 6 to both sides. 0 plus 6 gives me 6, divide by 2, and my x-coordinate is 3. Now, because these are x and y, I'm going to write my answer as a coordinate pair, and I'm going to check it in the one that starts with 3. And there is my check. You can pause the video and check against yours, or just if you need to kind of understand something better, please feel free to do that. Okay, last one for today. Stop the video, pause it, and see if you can do this one. Okay, now that we're all back together, let me show you my journey, my path that I chose. I chose to multiply the top one by 3 and the bottom one by 2. I'm aiming, my goal is to get the same number here off by a sign. In this case, by doing that, I'm going to have a 6 and a -6. So I multiplied the top by 3, 3 times 4, 3 times 2, 3 times 14. I multiplied the bottom by 2, 2 times 7, 2 times the -3, 2 times the -8, and I'm ready to eliminate. This time, the y is going to eliminate. I add these together, and I get 26x equals, and 42 minus 16 is 26. Divide by 26, and my x-coordinate is 1. I chose to put it in the top for that x right there. 4 times 1 is 4, and here I am at a two-step equation. We would Woodruff bubble right here, subtract 4, and I got 2y equals 10. Where is it? Okay. Divide by 2, and the y coordinate is 5. I'm going to write that as a coordinate pair, and I'm going to check it in the equation I did not use here. So since I used the one that started with 4, I'm going to check it in here, and there is my check. So even if our equations aren't set up to eliminate by multiplying one of the equations by the same number all the way across, or multiplying the two equations by two different numbers, we can set it up to eliminate. Just to show you, what happens if it's parallel, what happens if it's the same line. So, it would be something like this. If you look here, in this case, I'm going to multiply the top equation by -3. And when I multiply that top equation by -3, this is how my new system looks. So 2 times -3 is -6. -3 times -3 is +9. 6 times -3 is -18. And when I add down both both variables eliminate, and I get that weirdness, which we know from our talk on substitution, means that there is no solution. And if we had graphed those, the lines would be parallel. In this system, I'm trying to see how I can eliminate. I'm going to multiply the top equation by -3. Now remember, that's not the only way to get to the answer, but that's just the way I chose. And when I multiply -3 times x, I get -3x. -3 times the +4 is going to give me that -12 in front of the y, same thing as -12y. And don't forget to multiply the 1 by the -3. And then I look at the bottom equation, and again, when I add down, everything eliminates, and I end up getting 0 equals 0, which is a true statement. And that means they are the same line. And if I, graph them, I would see them basically on top of each other. It's the same line. And that would be infinitely many solutions. So I hope this helped you kind of get back into solving systems, graphing, using substitution, elimination, and a little bit further with elimination. I will be posting a worksheet for you to try. And in a little while after that, the answer key for you to check. So thanks for your attention, guys. I miss you all. Have a great day.